So that is equal to integration from 0 to 1. Now a minus b whole square, that is a square minus 2ab plus b square. So use that formula, we get x square minus 2x e raised to x plus e raised to 2x. Okay, so this equal to the integration of x square. What is integration of x square? X cube by 3. This minus 2 is as it is. What is integration of x e raised to x? Now to find integration of x e raised to x, we have to use this property, that integration x e raised to x dx. Okay, integration of x e raised to x dx, that is equal to x is as it is. Okay, x is as it is. Basically we use this property, this function integration uv dx, that is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on, right, where u is as it is. v1 means integration of v minus u dash. This u dash is derivative of u. Okay, v2 means integration of v1 plus u double dash v3 minus u triple dash v4 plus and so on, right. So we use this formula to find. This is basically coming from the integration by parts, okay, which you already studied in 12th standard. So x is as it is, the integration of e raised to x, that is e raised to x, minus the derivative of x, this is our u, so the derivative of x is 1. Okay, 1, and again v2, that means integration of v1. What is our v1? E raised to x. So the integration of e raised to x, that is e raised to x. Okay, now plus u double dash, the derivative of u dash. What is our u dash? U dash is 1, but the derivative of 1 is 0, so the other parts automatically cancel, right, because other parts become 0. So this is our integration of this term. Okay, and that can be expressed as e raised to x will be common, x minus 1 into e raised to x. Okay, so the integration of x e raised to x, that is equal to x minus 1 e raised to x, and that we use here. You can see integration of x e raised to x, that is equal to x minus 1 into e raised to x, plus integration of e raised to 2x, that is e raised to 2x by 2, integration from 0 to 1. So put the value of 1 instead of x first of all, so you will get 1 by 3 plus instead of 1, when we put here, instead of x, when we put 1 here, this part becomes 0, so plus 1 by 2 e square. Okay, e square by 2. Now put the value 0 instead of x, so this part becomes 0. Because of we are interchanging, we are changing the limits, already we have minus 1 between the two values, so minus and this minus 1, so that is again minus and 2 plus minus 1 by 2. Okay, so when we solve it, that is exactly e square by 2 minus 13 by 6, this is 1 by 3 minus 2 minus 1 by 2, 1 by 3 minus 2 minus 1 by 2, that is equal to 13 by 6. Okay, so that's why distance of fg, that is equal to norm f minus g, that can be expressed as square root of inner product f minus g with f minus g, that is equal to square root of e square by 2 minus 13 by 6. Again we find norm f square, that is equal to inner product f with f, that is equal to integration from 0 to 1 f into f. What is our fx? X into x, so x square, integration of x square is x cube by 3. 0 to 1, so you will get 1 by 3. So norm f square is equal to 1 by 3, so norm f is equal to 1 by under root 3. Okay, so here is the answer, because we only need to prove that we only need to find distance of fg and norm f. So we already find that distance of fg is equal to square root of e square by 2 minus 13 by 6, and norm f is equal to 1 by root 3. Okay, so here is the complete the solution of question 5a. Next is question 5b. Let R3 have the Euclidean inner product. Use Gram-Schmidt process to transform the basis u1, u2, u3 into an orthonormal basis where u1 is equal to 1, 1, 1, u2 is equal to minus 1, 1, 0, and u3 is equal to 1, 2, 1. So here these three are any basis vectors for R3. Okay, we have to convert this three basis vector into an orthonormal basis vector, and first of all, to convert any basis vectors from orthogonal basis vectors, that for that we have to use the Gram-Schmidt process, right, to convert any basis vectors from orthogonal basis vectors, and for that we have to use Gram-Schmidt process, right. There is some formulas that, let's take v1 is equal to u1 and then formula for v2 and v3. Now when we get the value of v1, v2 and v3 from that orthogonal basis vector to a orthonormal basis vector, what we have to do, just dividing by its norm. Okay, when we get orthogonal basis vector v1, v2, v3, and now we want to find the orthonormal basis vector, right. So what is the meaning of orthonormal basis vector? The not just only the inner product of any two vector is 0, but its norm is also 1. So if orthogonal vectors, to convert from orthogonal vectors to orthonormal vectors, we have to just divide by each vector by its norm. Okay, so first of all we use Gram-Schmidt process to convert these three vectors, these three basis vectors u1, u2, u3 into orthogonal basis vector. Okay, so let's see. v1 is equal to u1, that is equal to 1, 1, 1. Okay, now here is the formula for v2. v2 is equal to inner product u2 v1 upon norm v1 square. v2 is equal to u2 minus inner product u2 v1 upon norm v1 square into v1. So for that we have to find inner product u2 v1. Okay, for that we have to find inner product u2 v1. Now what is inner product u2 v1? You can see inner product u2, this is our u2 and this is v1. So just a dot product, minus 1 into 1, minus 1 plus 1 into 1 plus 1, and this is 0. So minus 1 plus 1, that is 0. Okay, so basically this inner product u2 v1 we get 0. So that's why v2 is equal to nothing but just u2. Okay, because of this part becomes 0. Now you don't need to find actually norm v1 square, just put the value of norm v1 square, but otherwise we know that this part becomes 0 because this inner product u2 v1 is 0. Now norm v1 square, that is 1 square plus 1 square plus 1 square, that is 3. Okay, 3, and this is v1, put the value of v1, but this part becomes 0. Okay, so v2 is nothing but u2, that is minus 1, 1, 0. Now we find v3. Here is the formula for v3, that is u3 minus inner product u3 v1 upon norm v1 square into v1 minus inner product u3 v2 upon norm v2 square into v2. And for that we have to find inner product u3 v1. See, this is the formula for here we find u3 v1, inner product u3 v1. Now what is our u3? This is our u3. You can see this is our u3, 1, 2, 1, and this is our v1, 1, 1, 1. So inner product u3 v1, that means the dot product using the Euclidean inner product, that is nothing but the dot product. So 1 into 1 1 plus 2 into 1 2 plus 1 into 1 1. So 1 plus 2 plus 1, you will get 4. Okay, so inner product u3 v1, that is exactly 4. Now inner product u3 v2, inner product u3 v2. So this is a 1 to 1 u3 and v2. What is our v2? That is minus 1 1 0. So 1 to 1 into minus 1 1 0, that is 1 into minus 1 minus 1, okay, plus 2 into 1 2 plus 0. So you will get 1. So inner product u3 v2, that is equal to 1. And now norm v1 square, that is we already have here norm v1 square, we know that 3, and norm v2 square. Now what is norm v2 square? v2 is minus 1 1 0. So norm v2 square, that is equal to 1 plus 1 plus 0, that is equal to 2. Okay, so put all these values in this formula. Inner v3 is equal to u3 minus inner product u3 v1 upon norm v1 square into v1 minus inner product u3 v2 upon norm v2 square into v2, that is equal to u3 is 1 to 1 minus inner product u3 v1, that is 4, norm v1 square, that is 3 into v1 1 1 1 minus u3 v2, inner product u3 v2, that is 1. You can see this is inner product u3 v2, that is 1. So 1 norm v2 square, that is 2. So 1 by 2 into minus 1 1 0. The v2 is minus 1 1 0. So 1 to 1 minus 4 by 3 into 1 1 1, that is 4 by 3 4 by 3 4 by 3, and then minus 1 by 2 into minus 1 1 0. So minus 1 by 2 minus 1 by 2 0. So here is the solution, 1 to 1 minus 4 by 3 4 by 3 4 by 3 plus 1 by 2 minus 1 by 2 0. When we solve these equations, not just to solve this equation, just addition, 1 minus 4 by 3 plus 1 by 2, 1 minus 4 by 3 plus 1 by 2, you will get 1 by 6. Again 2 minus 4 by 3 minus 1 by 2, you will get 1 by 6, and 1 minus 4 by 3 plus 0, that is minus 1 by 3. So this v1 v2 v3 are now orthogonal basis vector, but we have to find orthonormal basis vector. So basically you can see the inner product of v1 v2 v3 of any to each other, you will get 0. Okay, you can see v1, what is our v1? This is our v1 1 1 1. Okay, dot product of 1 1 1 with minus 1 1 0, you will get 0. 1 into minus 1 plus 1 into 1 plus 1, and 0 into 0 0. Now inner product v1 v3, inner product v1, that is 1 1 1, inner product v3, what is 1 by 6 minus 1 by 3. So 1 by 6 into 1, okay, 1 by 6 into 1, you will get 1 by 6 plus 1 by 6 minus 1 by 3. So 1 by 6 plus 1 by 6 minus 1 by 3, you will get 2 by 6 minus 1 by 3, 2 by 6 is 1 by 3. So 1 by 3 minus 1 by 3 is 0. So again inner product v1 with v3, that is also 0, and inner product v2 with v3, inner product v2, that is minus 1 1 0, dot 1 by 6 minus 1 by 3, that is minus 1 by 6 plus 1 by 6 plus 0. So that is again 0. So you can see v1 v2 v3 are just orthogonal basis vector, but they are not orthonormal basis vector. We want to find the orthonormal basis vector, so that's why we have to divide each v1 v2 v3 by its norm. Okay, so find norm. v1 is equal to 1 1 1, so norm v1, that is equal to under root 1 square plus 1 square plus 1 square, that is under root 3. v2 is minus 1 1 0, so norm v2 is equal to under root minus 1 square plus 1 square plus 0 square, that is under root 2, and v3 is equal to 1 by root 6. How we get this 1 by root 6? Just try to check. Okay, v3, what is our v3? 1 by 6, 1 by 6, this is our v3, v3 is 1 by 6, 1 by 6 minus 1 by 3. Okay, so norm v3, that is equal to under root 1 by 6 square plus 1 by 6 square plus 1 by 3 square, correct? So that is equal to 1 upon 36 plus 1 upon 36 plus 1 upon 9. Okay, and that is equal to 1 plus 1 plus 4, because we take LCM is 36. Okay, so here 9, we know that 9 into 4 is 36, so we have to multiply 4, right, upon 36, and that is equal to 4 plus 1 plus 1 6, 4 plus 1 plus 1 plus 1 plus 4, that is 6 by 36, that is 1 upon 6. So this is under root 1 upon under root 6. So how we get norm V3 is equal to 1 upon under root 6. Okay, so that's why this is norm V3. You can see norm V3 is equal to 1 upon under root 6. Clear? So this is our V3, 1 by 6, 1 by 6 minus 1 by 3, and we prove that norm V3 is equal to 1 upon under root 6. So we find orthonormal basis vector, and for that we have to divide V1, V2, V3 by its norm. So the required orthonormal basis vector is V1 upon norm V1, V2 upon norm V2, V3 upon norm V3. V1 is 1 1 1, so V1 upon norm V1 become 1 by root 3, 1 by root 3, 1 by root 3. V2 is minus 1 1 0, and norm V2 is root 2, so we get minus 1 by root 2, 1 by root 2 0, and this is quite interesting. V3 is 1 by 6, 1 by 6 minus 1 by 3. We are dividing V3 by norm V3, so that is 1 by 6 upon 1 by root 6. So root 6 become in the numerator and 6 in denominator. So that's why you will get 1 by root 6, 1 by root 6. So this two first coordinate you can understand. Now 1 by minus 1 by 3 upon 1 by root 6. So root 6 is numerator now, is in numerator, and 3 is in denominator. Root 6 can be written as root 2 into root 3. Okay, and 3 can be written as root 3 into root 3. So 1 root 3 will be cancelled out, and this is under root 2. This is actually minus 2 by root 6, but that is also can be written as minus under root 2 by under root 3. Okay, so here is the complete the solution of this question paper up to question number 5. Thank you.